Hi guys, so we're going to be starting the stream now. It's basically the same as what I was doing yesterday, which was a number theory thing on Alcumus. So just solving some number theory questions, and then once I finish those, I'll just try to go on to the next unit, right? So this is how far we've gotten so far. We've done I think like 12 or 11 or 12 different sections already, and there's this much left. So we're almost halfway done, I think. So it's going pretty well. And that's all we're going to be doing today, and I'll show my work on the whiteboard next to this. Also, as you can see from the title, every subscription that I get here is going to be 10 push-ups. uh, I'll do them here. I don't know if you'll be able to see them from the stream though, so if that doesn't happen, then okay, wait, I didn't show this, but yeah, so basically this is where we are right now. We've done the first 11 or 12 units, something like that, and there are these many left, so not too bad. And yeah, I'll show my work over here on this whiteboard so that um, so that you can follow along and so that I can do the work properly. And every subscription is going to be 10 push-ups. Either I'll do that in this video or maybe in the next stream. Then I'm not sure, but that's the plan right now. Okay, so everything is ready. Let me just test that the pen and everything is working. Yeah, okay. So let's continue then. How many base 10 integers are exactly 4 digits in their base 3 representation and exactly 2 digits in their base 6 representation? So if it's exactly 2 digits in its base 6 representation, what does that mean? That means it's going to be like this, right? This is the ones place, this is the sixes place. So the maximum value you can have then is going to be 35. You can have 5 here and 5 here. So it's 55 base 6 is 30, which is 35, right? Okay, so 35. And okay, so it goes from like 1 to 35, right? That's the first criteria. Exactly two digits. And then with 4 digits in base 3, that's basically so the maximum value and the minimum value. If it's got 4 digits in base 3, then this has to be a 1, right? Oh, sorry, it's not 1 to 35 because there has to be, if it's exactly 2 digits, the first one has to be at least 1, and then this one has to be 0. So it'll be 10 base 6, which is 6. So it's from 6 to 35. Over here, meanwhile, the minimum value we can have is 1000 base 3. So this is 13927. So it begins, the minimum value is going to be 27. And then you go until like whatever, some big value. It'll be 80. Right? So how many numbers are there in common? It's going to be 27 through 35, which is 9 numbers. Right? 9 different numbers. Okay, good. Suppose that b is a positive integer greater than or equal to 2. When 197 is converted to base b, the resulting representation, okay, so 197 base 10 is converted to base b. The resulting representation has 4 digits. What is the number of possible values for b? Okay, so 197 when you convert it to b. So 197 is equal to 4 digits. It's all base b. So this will be 1. This will be b squared. Sorry, that will be b. This will be b squared. This will be b cubed. So for how many different numbers can you have this work? First of all, since it has 4 digits, so um, b cubed must be less than 197. But at the same time, is there anything else we can say? Obviously, we know this, and that actually makes our work a bit easier already. So we know that b is, so the minimum value is 2. Then you can go until you can have 3, 4, or 5. All of these, when you cube them, they're less than 197. And then obviously 6 is too much. So these are the possible values right now. Now we need to narrow down a bit more though. So this is the same thing as, so the maximum value, and let me just check that you can see what all I'm writing in case it got cropped out. So the max is equal to b to the 4th minus 1, right? So that means 2 doesn't work because that isn't 197. It's too little. Same with 3, right? 3 to the 4th is way too little. 4 works, and 5 obviously works as well. So that means it's just 4 and 5, so 2. Yeah, and it says over there 4 and 5 work. Perfect. Express this. Wait, we need to go back here. The point is to get everything to blue, not to green. That's what we're doing here. So if this is written as a fraction a over b, with a and b being positive integers with the greatest common divisor of 1, what is a plus b? Okay, so it's 0.1331. Wait, this is actually not bad at all. This is 1331, right? Let's scroll down a bit. Over 9999, right? That's what it is. Obviously, there's an 11. So this is 11 cubed divided by 11 times something. What is that something though? Because 9 minus 9 plus 9 minus 9, that's 0, which means it is divisible by 11. It shouldn't be hard to figure it out, right? It should be um what is this? I'll just do the long division and see. I should know this, so it's isn't that hard. So this will give you 9, right? Minus 99, 0, pull down 9, 0. Oh, 909. Yeah, that makes sense. So it's 909. So this is now 121 over 909. This is a multiple of 9. This is not a multiple of 9. That's just 11. And there's no more, there are no more multiples of 11 here. So this is what we have, right? Now what are they asking us for? So yeah, we've got greatest common divisor 1. Now we have to do a plus b. So just add them up. That will give you 1030, right? 1030. Yeah, same thing. You factor out an 11 and then you add them up. Okay, I think this should be the last question we have to do over here. How many more digits does the base 3 representation of this have than the base 8 representation of the same number, 987? So 987 is our mystery number here. So we're doing this and this, base 8. So in base 8, um, sorry, this would be 8 to which power? So 8 to the second power, no, obviously not that. 8 to the third. So it'll be like 4 digits, right? This will take up 4 digits because you need, so basically 1, 2, 3, 4. This will be 1, this will be 8, this will be 64, this will be 512. No matter how many of these you have, these will be less than 512, right? Like 777 is a maximum. That'll be 511. So to get to 987, you need at least one of these, which means there'll be 4 digits. Similarly, over here, we basically need 3 to some power x is less than 987. And wait, we don't need to do all that. 729, so that's 3 to the 6th, right? That's 3 to the 6th is equal to 729. So we need to go, um, that level will work. So this is enough. 6, which means, because it's 3 to the 6th, we need 7 digits. Because the first digit is 3 to the 0th, so you have to add one more. So it's 7 digits, 4 digits, so 7 minus 4, which is 3. Okay. Convert this to base 5. Perfect. I think there is a shortcut for this, like a faster way to do it, but I kind of forgot that. So instead, let's just um we'll see if we can manipulate it somehow. 1357 base 10. So that'll be well, wait, we know I'm stupid, sorry. Basically, yeah, 5 to the 5 cube. 5 to the 4th is 625. So we'll have one of those. Maybe we'll have two of those. Yeah, I think we'll have two of these. This will give us 1250. What all do we have after that? Then we've got, so then we skip the 125. There's nothing over there. In the 25s, we should have four of them. Then in the fives, we have just one. And then here in the ones, we have two. This will give us 7. This will give us 107. And this gives us 1250. So that will give us 1357. So 20412. 20412. 20412. Great. One more. What is a base 6 equivalent of 999? So this is again pretty similar. We'll go for 4 digits here. This is 216. This is 36. This is 6. This is 1. So we'll need 4 of these. That'll give us 864. What's left over is 133, right? So we can take 3 of these. That will subtract off 108, leaving us with 25. Yeah, 25. So that's 4, 1. So 4, 3, 4, 1. 4, 3, 4, 1. Okay, wait, it's off. Let's just check our work again then once. 4 times 216 is 864. It's 999. Okay. So let's see what we did here. 1, 6, 36, 216. The base, like, that part is done correctly. 216 times 4, it's 999. Yeah. So that is 800, and then 40 and 24. So 864. That leaves us with 133. Oh no, 135. My bad. 135. So everything will be the same. We just add 2 more here, making this 3. So it should be 4343. Okay, done. We mastered that. Now we're on to this one. Converting to base 10. Okay. These ones don't seem that hard. They're just like manual, I guess. So let's see. 432106, 43210, and 321. 43210 and 321. That's correct, right? Yeah. Okay. So this is a bit long. Well, actually, this isn't bad. It's going to be 3 times 6 cubed plus 2 times 6 squared plus 1 times 6. I won't write 1 times 6. I'll just write plus 6. And then the 0 obviously doesn't do anything. Over here we have minus 7, sorry, minus 3 times 7 cubed plus 2 times 7 squared plus 1, or again just 7. I think the idea is that they want us to cancel out stuff now, right? So we basically got 3 times 6 cubed minus 7 cubed plus 2 times 6 squared minus 7 squared plus 6 times, basically, sorry, 1 times 6 minus 7. So that's just going to be minus 1. Okay, we can like flip the signs. And then over here we've got 4 times 6 to the 4th. Okay, over here, what is this going to be? 6 squared minus 7 squared is just negative 49 and 36. So 13, so negative 26, so minus 27. Then what is this? So 7 cubed minus 7 to the minus 6 cubed is equal to 7 minus 6. So that's 1 times 7 squared plus 42. So 7 times 6 plus 36, 6 squared. So that's 49 plus all this, right? 49 and 36. This adds up to 85. Right, this becomes 15,518. So 85 and 42. 127. Then you multiply it by 3. We can't forget that. Oh, wait, I don't think you can see this stuff anymore. So let's just move out of it. All right. Multiply it by 3 now. So that gives you 1 or 21, 2. So this 6, 8, and 3, 381. So it's minus 381 minus 27. If you add that up, you get just 408. So minus 408. 4 times 6 to the 4. So that's 1296 times 4. Right, that should be right. Minus 408. So easy enough. This is 1, this is 5. This becomes 76. 5176. And I'm sure I made some calculation mistake. Okay. Um, let's see, what could we have done wrong? 6, so 216 goes to 1296. You multiplied it by 4. So that's 1300. Wait, that's completely wrong. I'm guessing I did all the calculations on the side correctly. 1296. I multiplied it completely wrong because it's 1300. So this should be 2 instead. Right? This should be a 2. So this will remain as 76. This 51 will go to um 48, I think, right? So 48, 76. I don't know, 4876. Let's try it. Okay, so some city mistake somewhere. Uh, yeah, you just have to like evaluate it like that. How old is he in base 10? Okay, so 2 plus 6 plus 18. 18 plus 6 plus 2 is 26. 26 plus 27, 52, 53. Okay, good. Again, so let's just do this normally. No need for any fancy stuff. 213 base 8. So 213. I shouldn't even say 213, right? Because that's not really what it represents. 142 base 7. Let's just check. 142 base 7, 213 base 8. Okay, great. So this is going to be 864. So 128 plus 11, so 139. Minus over here we have 49 plus 28 plus 2. So this is 79, right? Which means the answer should just be 60. Okay, let's check. Yeah, it still says 379, but in case it's not updated, let's just check. 1 second. Yeah, okay, nothing happened. So continue. 1 second. Okay, if n equals this, where d represents a base digit. Okay, what is the sum of all possible values of n in base 10? Okay, so this is a bit irritating, but 1d for 1, 1d for 1 base 8, 1d for 1 base 8. There's definitely a way to like shorten the work here. So d can equal 0 all the way until 7. So this is a total of 8 possibilities. So all the rest of the stuff will be the same, right? It's 1 plus 32 plus what, ignore the d stuff for now. This is 64. So this will be 512. Okay, all of this will be included each time. 8, like 8. You multiply it by 8 because it's happening 8 times when you add it up. So this becomes 545, right? 545 times 8. So this becomes, wait, let me do this in my head actually. 45 times 8 is I think 320. Oh no, 360, right? Yeah, 360. And then 5 times that is obviously just going to be 0004. So 4360. I didn't end up doing it in my head, but okay, 4360. So that's always going to be there. Then besides that, we have 64 times 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. That adds up to, so the 8 times 7. So that should add up to 28. So it's 64 times 28. Um, let's just multiply that. 12, 48 plus, um, sorry, 48 plus 16 is 64, and then here 32. So 2781, 1872. So that should add up to this, unless I've messed it up. 142. No, seems right. 6232. Okay, again it's off. Okay, this is pretty stupid now. Let's just make sure I've done everything here correctly. So, all the way from the beginning, our number is 1d for 1, right? So, there's going to be the first one is 512. We skip the d because we're adding that in later. Um, then we have 32 because it's 4 times 8, and then we have 1. Right, so 1 plus 32 plus 512 does become 545. Did I multiply it correctly? So that should be 0 4, yeah, 4000 and then 360, so 4360. Did I do the addition here correctly? Let's check that. 2 and then 3 from 13 plus 1. So that again is 2. You carry over one more, so 6. 6, 2, 3, 2. That seems right. Like all of that seems right. So then maybe I made a mistake over here on this side with 64 and 28. So it is 64 times the sum of all the different values you can have, which are 0 through 7, right? And they add up to, basically they add up to, did I not divide by 2? There are 8 different numbers. They all add up, like the different pairs will add up to 7. 1 and 6, yeah, 2 and 5, 3 and 4. So they add up to 28. Did I multiply it wrong? That's possible too. I did 16 plus 48, which is 64 again. What have I done wrong here? I'm not going to use a calculator because that's not allowed, I'm sure. Okay, so this is 48. This is 8. It's not 16, it's 8. I don't know how many stupid mistakes I've made like this. So this should just be 56 instead. So this is 2, this is 9. Then this becomes 7. Right, so 2, 9. So you add these two up to get 9. Then you add these two up to get 7 and then 1. So this should be 1792. So this becomes a 9, this becomes a 7. So this will become a 5. This will just become 1 less. So 6152, I think. Let's just check again actually. Why mess it up now when did this close? This is what we're adding, right? So this becomes a 2, this becomes a 5, add 1 over here, 10, 11. So this becomes a 1, and then this becomes 6. So 6152. 6152. Okay, finally. Um, what is this when expressed in base terms? 62 base 7 plus 34 base 5. 62 base 7. This one is a lot easier. 62 base 7 plus, what is it, 34 base 5? Yeah, 34. So this is just going to be 7. So 42, 44 plus 19, which is 63. So that should be good. Are you able to see what I'm... yeah, I think you can see it. Maybe you can't see the answers actually. So let me move this here. I'll move it to the top right. Next one. Okay, they skipped it again. So let's do this last one. 427 base 8 to base 5. 427. So this becomes 7 plus 8 times 2, 16 plus 64 times 4, which is 256. So this becomes, what does it become? 272, 272 and then 279. Let's make sure that I did that correctly again. Yeah, that seems right. Now with 5, we need 4 spots. So this is the 125 spot. So we'll have 2 over there. That takes care of 250, leaving us with 29. This is the 25, 5, and 1. In the 25s, since we've already got 250, we need 29. So we'll put 104, 2104. That should be right again, hopefully. And I just want to make sure that they aren't doing any like special tricks here. So yeah, all the answers are pretty similar to what I've been doing. So not too bad. Express 249 base 11 plus 3ab base 12 um, as a base 10 integer. Okay. So, and a and b are like 10 and 11, right? Yeah, over here, 10 and 11. 249 base 11. Let's make sure we write this correctly. 249 base 11. 3ab base 12. 3ab. Okay, this is going to be 44 plus 9 plus 121 times 2. So that's 242. Let's add this up. So this becomes 286, 295. I just want to be extra careful here. That's why I'm going slowly right now. This is going to be meanwhile, so 144 times 3, which is what? That's 440, 456, I think. right? 456, because it's, no, 436, I think. No, 456 is, no, and it's none of them. I know what I'm doing. 420 plus 12, so 432, right? That's what it should be. Okay, plus 12a. No, and a is just 10, so that's plus 120. Plus, and then b is 11. Yeah, so plus 11. Great. This becomes 432, so it becomes 563, right? This becomes 532, 552, 562, 563. Add them up. 8 over here. Here you've got a 5, here you've got an 8. 858. Finally, done. With that, we finished that unit as well. So now we can come back here. Base number problem solving. A magic square is an array of numbers in which the sum. Okay, I know that. The diagonal stuff. The numbers in the magic square are not written in base 10. For what base will this be a magic square? So you need it to be a base that's at least 15, right? And oh no, never mind, never mind. What's the biggest digit you have anywhere? It's 4. So it has to be at least base 5. And then we have, so let's just call the thing x, right? That should be easy enough. Whatever base it is, we'll call it x. So it becomes 2 plus 4 plus 4. So that's 10. 10 plus x. I'll write it at the bottom here. You should be able to see it. 10 plus x is equal to, and then we can do it with any other row, right? So let's do it with the first column, 13, 3, and 4. So that will give us x plus 10 again. Okay, that's not helpful. We'll do it with the second one, right? That will give us 1 plus 4, so 5 plus 2x, which means that, yeah, x is 5. So the base is 5 again, which I'd only said 5 in the beginning because that's the minimum base, since there's a 4 digit here. I didn't guess or anything, so that's good. The first 2007 positive integers are each written in base 3. How many of these base 3 representations are palindromes? So to be a palindrome, this one will have to be, let's see. Okay, this is a bit difficult. Let's see. Oh, wait, I don't think we need to worry too much about it, right? Like basically, until where? Like, what's the biggest number you can have with 2007, right? 2007 is equal to, we need to find a power of 3 that's close by. So we've got 729. And you can multiply 729 by 2, and that will work. So 729 is equal to 3 to the 6th power. So you'll need 7 slots. 1, 2, 3, 4, 5, 6, 7. These 3 don't matter. They can be anything. These 4 do matter, right? This one can be either 0, 1, or 2. Um, let's break it up into a few cases as well. I just want to see like what the limits are. Let's just say this one is 1 for now. It can't ever be 0. And we aren't going to make it 2 yet either, because it'll just be easier like this. Okay, so let's say this is 1. Then this can also be 0, 1, or 2. This can also be 0, 1, or 2. And the other 3 are, they already, they're forced by these 3. So when this is 1, so when the first digit, let's call this x, when x equals 1, then how many do you have? There's only one choice for this. There are 3 choices, 3 choices, 3 choices. So that's 3 times 3 times 3 times 3 times 3, which is 27. What about when x equals 2? Now we have to be a bit more careful, because now it's possible that they become more than 2007, right? Like when this is 2. So again, here there's only going to be one choice for the first one. Now, what about the second one? Can that be a 2 as well? Um, this is going to be 243, right? 243. Yeah, I think it can. Um, but if that's a 2, okay, let's just write down the bases as well. So this is 243, this is 81, and then this is just 27. Then this will be 931. Okay. So basically, if this is 2, how many, like what do you have left? What if you multiply this by 2? That'll give you 1458. Subtract that from 2007. Let's see, that will give you 549. 549. Okay, that's fine. Let's break it up into cases again. Okay, so now let's call this y, by the way. So when y equals 0, so we've already said x is 2, y is 0. That's first. Then you're fine, right? Then this can be anything. Then this can be anything. So that's 3 times 3. That's 9 options. When y is equal to 1, then you have to subtract off 243. So minus 243. And you'll also have to subtract off a 3. But I'm not, that's just so insignificant that I'm not really counting it right now. And nor am I counting the 1 over here. So this gives you 306. And when you've got a 306, I think you're fine with anything else you put. So again, you'll have 9 options. Important stuff happens though when you've got, wait, yeah, okay, that's nice. Um, and I think that's correct as well, right? That should be right. Because 306, even if this is 2, that's only 160, and then all the other ones will be less. And these don't add up too much, they're pretty insignificant. So that's fine. Then the last case is when y is equal to 2 as well. And here I don't think you can have anything. Right? You'll have to have 0 and 0 or something like that. Let's just check though. Okay, so um, when y is 2, you subtract off another 243. Right? That gives you 57 plus 6, so 63. That means that this has to be a 0. So has to be a 0, which means that this is also a 0. So this is 0, this is also 0. You've got 63. Remember that we've already taken 2 and 2 over here. So this will become 2 and 2, which means you have over here, this is basically equal to 6. This is equal to 2. So that's 8. So you subtract 8 over here. And now this gives you 55, which means 27 can be 0, 1, or 2. So 27 can be 0, 1, or 2. So that's 3 choices here. So this in total over here, how many? We have 27 plus 9 plus 9 plus 3. So this is 48. Okay, it's wrong. Let's see. We might have made a silly mistake somewhere. Oh, wait, I'm so stupid. This is with 2007, right? And this is covering all the digits, but this is only taking into account when x is equal to 1 or 2. Yeah, okay, not too bad. What about when x is equal to 0? We forgot about that. That's also allowed, right? Because then it'll just be some other number. When x is equal to 0, then we have, well, then this becomes, no, then we ignore this. Then it's just this, and and that, which should mean that you can have any of the 3 options here. Then basically, like, everything can be whatever it wants, right? So you can have 3 options here, 3 options here, 3 options here. But I think we have to be a bit more careful, because if this is also a 0, right? Let's redo it with just, so sorry. Okay, so far we've got 27 plus 9 plus 9, that's 45, 48. Right now we've got 48. Now we're considering this case, which is an important case. If x is 0, so if the first one is 0, then there are only 6 digits left. If this one is also 0, now there are only 5 digits left. If this one is also 0, now there are only 4 digits left. This one is 0, you know what I mean, right? There are only 3 digits left then. So here we have to be extra careful. So what do we do? Do we do casework here again? Like just full on casework or something else? So if this can be one or two, right? Then this has three options, this has three options. So this becomes a total of 2 times 3 times 3, right? 2 times 3 times 3, which is 918. So plus 18. Done. Now what about when this is 0? I think this is the way to go about doing it. When this is 0, now there are only 5 digits. So now we've got this, and then these two. Sorry. So these three matter. Right? Now what about when this is 1? So everything else is 0. That's what you said. Uh, then this can be 1 or 2. And then this can be three options, this can be three options. So again we get 18, right? Again we get 18. But now if this is 0, then you've only got four things left. Um, you get two options here, three options here. So you have plus 6. That's if it's 1 or 2, right? Then the last option, then again we can say what if this is 0 though? Then there are only three numbers left, right? And then over here, same exact logic. There are two options for this, three options for this. So that's again plus 6, I think. And then once you have that plus 6, then what if this is 0? Right? Then this cancels out. Then over here, you can just have 1 or 2 again, 1 or 2, and that's all. Right? So just plus 2 now. But what if this is 0? Then it's just one digit. So again, it's going to be plus 2. Okay, that was a lot. And I probably should have found some faster way to do that. So we'll check the answer after this. Hopefully this is right. I'm not even sure if it is. So this becomes 20, 40, right? So this becomes 20, this becomes 20. So it's 40. 40 plus 48 is 88, right? 40 plus 48, 88. Plus 6 plus 6. Okay, plus 12. So this is 100, which seems like, it seems like that's, I don't know. Let's just put it in and see. Okay, it's correct. Why is it correct though? Let's see. It is convenient to begin counting with at most 7 digits. There are two palindromes of length 1, namely 1 and 2. There are also two palindromes of length 2, namely 1, 1 and 2, 2. For each palindrome of length. So you multiply it by 3, 3, 3, 3, 3, or whatever. Uh, and then you basically, okay, I see what they did. So they worked the opposite way. Right? They said, what about with one digit, two digits, three digits, and so on. So they did that, and then once they were done with finding all of them until 54, which is the last one that by using the bases, right? That's the seventh one. That's with 3 to the 7th. So that was the last one, right? And then, sorry, 3 to the 6th because that's 7 digits. After that, they subtracted 6 because those ones don't work. That's kind of what we did, but we did it in a, that's a step that we did all the way at the beginning, right? But we did it in a convoluted way. They just like manually found them in a slightly faster way, and then besides that, it was all the same. They just didn't take as long in listing out everything and putting the stuff there, but not too bad. Still, at least we got it correct, right? That's good. Let me just see like where exactly this question came from. 2007 AMC 12. Like which question number was it? Okay, so it's, what's the question? It's the first 2007. Okay, I don't think it's in this one. I've let's just make sure though. Okay, so it'll be in 12A, 12B. So I'll just change the link there. And what's the thing? The first. Okay, not bad. Uh, question 21. So it's fine. Okay, yeah, we need to go back here. Let's continue. What is the greatest three-digit base 8 positive integer that is divisible by 5. Express your answer in base 8. Okay, so that's fine. 3 digit, right? And what is the greatest or what is the least? What is the greatest? Okay. So we obviously want to make the first one 7. Then we want to make this one 7 as well, which means you have 64. So this is 8 and 64, and then 1. You got 64 times 7. To take out like all the multiples of 5 over there, basically you can do 65 times 7 minus 7. So it's negative 7, which is just 3. Right? Then over here you've got 8 times 7, which is 56, which is 1 more. So you just need 1 over here. 771. That should work. Wait, but we can also make the 1 a 6. That's even bigger. Right? So 776. Perfect. Compute this. It's all in base 3 though, so not bad. Wait, actually it's not bad at all. We can actually do the arithmetic with this. The second and fourth terms, they when you subtract them, they give you 1 1 base 3. Right? That's it. 1 1 base 3. 1 1 base 3 is just 4. Right? So it's just 4. What is 121 base 3? 3 plus, sorry, 6 plus 9, 15 plus 1. Sorry, 1 plus 9, 10, 10 plus 6, 16. So it's 20 minus 1200 base 3. Right? What is 1200 base 3? Wait, this seems a bit off actually. 1 second. It's going to be a negative number, which seems wrong to me. So it's all in base 3, so we're not messing that up at least. How could we change it? 121, 2122. So 2122 base 3 minus 2111 base 3. Um, you can just make that 11 base 3 or like 1 1 base 3, however you want to say it. And that is 4. Then 121 base 3 is 3 plus 6, so 9. Sorry, 1 plus 6, that's 7. Plus 9, 16. 16 plus 4 is 20. Okay, and then when you subtract this, you just get, so that's 18 plus 27, so minus 45. So it's negative 25, right? And they want this in base 3. Okay, fine. So what's that? That's going to be 3 digits. 3 digits, and the first digit will be 9. So you have two nines. That gives you 18 out of 25. That leaves you with 7. So you put 6 1 221. Okay, it was negative. I don't know if you could put negative, so that's fine. Um, another wait. I think they moved us out of that. So let's continue this. Just hopefully this is our last question. What is the sum of all positive integers that have twice as many digits when written in base 2 as they have when written in base 3? So how will this happen? And they want the answer in base 10. So twice as many digits when written in base 2 as they have in base 3. How can we do this? So first of all, if there are 2 digits in base 2 and there's 1 digit in base 3, right? Then if you have 4 digits in base 2 and 2 digits in base 3. What are the rules for this? So this, it has to be less than 3 squared and it has to be greater than 2 cubed or something like that, right? Has to be greater than, sorry. So to make this happen, the minimum value for this is just 3. The maximum value, no, the minimum value is the minimum value for this, which is 2. So 3. Okay, this is 1, this is 2, this is 4, this is 8. So the minimum value is 8. The maximum value it goes until is 3 squared 9. So what? I don't think this is possible then. Similarly, oh, okay, over here you can put a 2 that gives you 1 0. But that's it. Right? If you put a 1 here, that's only one digit. So this gives you one answer. Then over here, how many do you have? You have, again, you'll have the maximum value you can have here is 8, right? And the minimum value you have here is 8. That's 1 0 0 0. And this is 2 2. 3 times 2 plus 2, 8. So any other number like 9, this will take up 2 digits here. 7 will take up 3 digits here. So again, you only have 1 over here. And if you go past this, then we have 1, 2, 3, 4, 5, 6 base 2. So 1, this will be 2 to the 5th. So it'll be at least 32. And over here, the maximum value it can be is going to be 27. So this is going to give you 0. And it's only going to get worse and worse from there. Right? 3 cubed. Next time you'll have 3 to the 4th and 2 to the 7th. Right? 2 to the 7th is greater than 3 to the 4th. This is 81. This is 128. So it'll keep on going like that because this is getting multiplied by 4 each time. This is getting multiplied by 3. So I think there should only be 2. Okay, wrong, wrong, wrong. Oh, I'm an idiot. It's the sum of all of them. Again, it's not actually the number. So I'm guessing it's just these then, right? So 2 is 1 and 8 is 1. So it should be 10. Let's hope that's correct. Okay, perfect, perfect. Okay, we got this part, which I think that's what we got towards the end. And then, yeah, besides that, it's fine. Palindrome, okay. The largest possible 4-digit palindrome in base 3 can be expressed as a 3-digit palindrome in another base b is greater than 2. What is b? The largest possible 4-digit palindrome. So that's just going to be like this, right? It's going to be 2, 2, 2, 2 base 3, which means this is 3 cubed, this is 3 squared, this is 3, this is 1. So it's 2 times 3 to the 4th minus 1 over 2, which means that this should be, um, am I doing the formula correctly? Yeah, I think I am. So that's just 80, right? 80. You can write 80 is equal to, um, well, let's see. It's some other base greater than 2, or what do they say? It's some other base, right? It should be written as A, B, A, or I'll just use other variables here. I'll use like X, Y, X, base B. So basically you have X times B squared plus Y times B plus X is equal to 80. But wait, we can think about this in another way, I think, right? So 80 is an even number. You have basically X times B squared plus 1. And then you have Y times B. For this to add up to an even number, either, so let's say that this is, okay, let's ignore that actually. I think we can just like do some guess and check or whatever here. That should work out. Because there's like very few numbers, right? Actually, no, wait, it's even easier than that. B is greater than 2. Did they say greater than or? Yeah, it has to be greater. So it can be 3, 4. Can it be 5? It can't be 5 because 5. No, it can be 5 as well. Never mind. 6 actually also works. 7 also works. 8 also works. 9 won't work because 81 is greater than that. But if you look at them, some of them don't actually work, right? Like 8 will be, let's just try it with each other. Right, this will be 10x plus 3y. Does this work for any integers? less than 2? No, right? Oh, wait, 1 second, 1 second. I don't think 3 even works. Right, 3 can't work because I don't think 3 can work because this is a nines place. So that doesn't work. 4 does, oh, because 64 comes here. So 4 doesn't work. 5 works because the next cube is greater. 64 isn't greater. So these won't work. So it's 5, 6, 7, or 8. Okay, perfect. So now we've gotten this far. Now I think we can do plug in some values and see what we get. Right, with 5 we'll have 26b. 1 second, because it's 25, 5 squared plus 1. So 26b plus, wait, sorry, 26x plus 5y. How can we get something like this? I don't think that will work because um you need to have this end with a 5 or a 0, and neither of those will happen in time. So 5 is out of the question. What about 6? 37b plus 6, so sorry, 37x plus 7 plus 6y. Again, 37, 74. Yeah, wait, 74 could work. And then 2. So I think it's 6. Right? Because you can have 2, 1, 2 base 6. Okay. And yeah, that gives you 36, 72, 78, 80. So it is 6. That's the answer. I think guessing and checking is fine. We know that converting 8 to 10 will result when the base is from 8 to inclusive. Oh, okay. They just converted, which actually that makes so much more sense because you know it's 80. That was kind of stupid, but okay. Fine. So you've got the answer now. Base number arithmetic. Add each of these up. Express your answer in base 2. Okay, it's 11, 1100, 101, and 11, 101. So let's see if I got those all. 11, 1100, 101, and 11, 101. Right? 11, 1100, 101, 11, 101. It's all base 2. So all of them are base 2. Which means we can actually add them up. Right? So if you do this, you get 101 and 11, and you can add it up normally. This becomes 211. So fine, we've got that. Then you can add it to 1100, which also works perfectly. That becomes 1212. Then you can add it to this, and now this is where it gets a bit more complicated. It's 10111. This becomes a 3, but a 3 is a, oh wait, I'm stupid. No, never mind. You can't have twos either. What am I doing? So all of this is wrong. This becomes a 0. Okay, this becomes a 0. That carries over a 1 here. That becomes 2, which again becomes 0. Carries over a 1 here, which again goes like this. So you got 1000 here now. And with that, we've gotten rid of these two. Now we add this to 1100. This one will become 0. This one will become 0. This one will remain 1. This becomes a 1 0. Okay, now we've got 11101. So this becomes a 1. This becomes a 0. This becomes a 0. Okay, careful now. So this becomes a 1, this becomes a 0, this becomes a 0 carrying over a 1 here. So this also becomes a 0 carrying over another 1 here. And now this is 3. So to make it 3, we just put 1, 1. So this is our answer now. And we got all of them. We added up all of them. Using the normal, like adding in a different base, using that method, not using any conversions or anything. So that's good. 1, 1, 0001. Okay, perfect. Got it. And I guess you could have done it all at once as well. That would have worked too. But that would have made it a bit more complicated. Okay, so if S, H, and E are all distinct non-zero digits less than 5, and the following is true. Yes, okay. So first of all, we know that 2H is equal to E, which means H is equal to 1 because they're distinct. It can't be 0. So H is equal to 1. E is then obviously equal to 2, which means S is equal to 4. If you add them up, what do you get? You get 6, 7. You want it in base 5, so that becomes 1, 2. Great. Natural numbers of the form. Okay, we need to go back there. Hmm. Find the positive base B. Okay, this is a bit harder. Well, actually, it's not that bad. There is a way to multiply and divide in different bases, but I forgot what it is. So instead, we'll just expand it out and see. So 5 times 23. 5 base B is just 5, right? Times, and 5 also tells us, by the way, that B is greater than or equal to 6. Or basically just B is greater than 5. Times 23. So this is 2B plus 3 is equal to B squared plus 5B plus 1. Okay, let's do this. So 10B plus 15 is equal to B squared plus 5B plus 1. So B squared minus 5B minus 14 equals 0. We'll get two answers here. One will be negative, one will be positive. B minus 7, B plus 2. So obviously B equals 7. Perfect. So it has to be 7 then. And I think, yeah, they did the exact same thing. You have to just plug it in and see. Consider the following two strings of digits. First, consider them to be in base 10 and then sum them to get n. Then consider them to be in binary, sum them, write the answer in binary. Then consider them to be in binary, sum them, write the answer in binary. Then interpret the digits of the sum as if they were in base 10 to get m. What is n minus m? Okay, this is so long though, so we have to like copy paste or something, right? I'll just copy paste the picture over here. In fact, I'll just copy it like that. This is the second one. Let's just drag them onto each other. Does it all fit? I just want to make sure it's aligned. Okay, great. Now let's do it in base 10 first, obviously, right? To get n. That's easy. That this becomes 1, 1, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1, 1. Since everything remained a 1 and nothing became a 2, it'll be the exact same in base 2. Um, and actually, it's easy to find out. How many digits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, let me just count it once more. I'll count from the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it'll be 2 to the 17 minus 1, 2 to the 16th. Actually, no, it'll just be 2 to the 17th minus 1, right? 2 to the 17th minus 1 will give you everything. Like if it was 1, if these were both 1 as well. So then we subtract off what we're missing. This is 2, 4, 8, 16. So we subtract off 16. And then this, if so, wait 1 second. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. And then let me just check. So 512, so this is 1024. That's 10. 11, 12, 13, 14, 15, 16. So the counting is done correctly. 2 to the 17th minus all of this stuff. So that's a lot. Um, but we still got this answer here to help us, right? So I wish I could use a calculator for this because this is at this one it's just like kind of subtraction. So it'll be irritating to do it. But okay, what is 2 to the 17th? 2 to the 7th times 2 to the 10th. 2 to the 7th is 128, right? Yeah, so 128 times 1024. This is like very long. 1024, so that's like 512 times 128. So I want to multiply this, then I want to multiply it by 2 again. Then subtract all this stuff. Then subtract that from this huge number over there. Okay, so 5, 1 times 1, so that's 1, this is 10, so this becomes 11. Here you have 40, right? 8 times 5 is 40, this is 42, 44. 4 plus 8, 12, 16 over here. So this becomes 6, this becomes 3, this becomes 5, this becomes 5, this becomes 6. 6, 5, 5, 3, 6. Then we multiply that by 2. 2, this becomes 12. So 1, 7, 0, 1 over here. Again 1, you carry over another 1, 12, 13. This is what we have. Now we need to subtract off 16, 1 and this. So basically remove 17. That gives you 1, 3, 1. Well, let's just add this up. That's the easiest, right? This is a 3, right? That's a wait. That was a 3, right? I think that was a 13. 1 second, it's all gone now. 1, 3. Yeah. Let's just add this up. That gives you 529. I'm pretty sure. Yeah. So now we just do minus 529. So this becomes 0. This becomes 10. Then you wait. How do you do this? I'm actually forgetting some of this. So to do 2 minus 9, you cut this and make this a 6, and you put a 1 there, right? That makes this 3, and that makes this 4. Then you cut this to 0 and make this a 9, right? So just 9 minus, sorry, you make that a 10. What am I saying? 10. So this becomes 5. Then this becomes 0. So does that make sense? Yeah, 543. And then 1 and 3 over here. Okay. 130,543. 130,543. 1 3, so 345031. 3. Okay, this is going to be impossible. Look at how much carrying over has to be done here. I wish I could take a calculator out for this because this is just like extremely. If they just removed 5 digits from each, the question would have been the same. Like the concept would have been the same. It would have just saved like all this time. But no. Now we have to subtract all this, right? So luckily most of it will be the same, but then we also have to figure out how to write the answer back there because it's going to take a long time. Okay, let's see. If anyone here is new, I'm probably looking pretty stupid doing a question like this, but this is just the other questions are better than this. They're not menial like this. So how do you do this? You keep on cutting each of them, right? Wait, can't we just do? We can do it the other way. We can do 130,543 minus 101111. Get this as a negative thing. Subtract that off from 1000000. Subtract that from a million. Um, yeah, subtract that from a million, and then put that over here, and then just paste everything in front of that. We can do that. But now this becomes much easier. This becomes a 2, this becomes a 3, this becomes a 4. This becomes a 2. So that becomes a 9. 10 minus 1, 9. 2. That's it. Now we do a million minus this. So 1 0 0 0 0 0 0 minus 29 for 32. So for this we'll just do, so this becomes 8, this becomes, and then everything else is like 9 minus, right? So this becomes 7 0 5 6, right? Um okay, this is 9, and I think that's it. So this is what we put over here, right? Let's slowly edit it now. And how many spaces does this take up? This takes up 6. So 1 2 3 4 5 6, and then that 1 becomes a 0. So let's just be very careful about this. If I get it wrong, I'll just use a calculator, I think, because this is 1 2 3 4 5 6. This is just way too stupid. Oh wait, I just realized you can't even see my whole screen. So let me just zoom out there for you. Hopefully you can see it now. And I'm also covering some of the work, but ignore that. So this is 9 7 0 5 6 8, and then this one, remember, this one becomes a 0. So this is our final answer. Okay, we're going to put 5 digits at a time. 1 1 1 1 1 1 2 3 4 5. So just put in 1 1 1 1. That's 5 ones. Then we put in 1 1 0 1 1 1 1 0 1 1. Then we put in 0 9 7 0 0 9 7 0 568. 568. Okay, it's wrong. I don't even care though. It's just such a, yeah. Let's just put in a random number. Let's put in the same thing. Let's just put in 0 and see what. Oh, they wanted to wait. When they said interpret it, okay. This is like completely my fault. So I got it correct though. Wait. Okay. You know what? I deserve it. I did all the work. I'm sure that it's close to correct, and for all that work, actually, what else would I have guessed? Like, it's probably something. So when they said interpret the digits of the sum as if they were in base 10, that they meant just change the 2 to a 10. I thought they wanted me to convert it to base 10. So I should have probably read it better and understood that better. But anyway, 0. I got it correct, so I'm happy about that. Natural numbers of the form 2 to the 2 to the n plus 1 are called Fermat numbers. In 1640, he conjectured um, that all numbers f sub n are prime, which is false. What is the units digit of f sub 1000? Okay, so 2 to the 1000. Okay, so it's 2 to f sub n. So f sub 1000 mod 10, right? Just a remainder basically. Or I'll just write remainder. Or units digit. This is not too bad. So if you plug this in, you get 2 to the 4 to the 500. 2 goes in cycles of 4, right? Like it's 2, 4, ends in 8, then it ends in 6, then it goes back to 2. Right? So 4 to the 0 will end in 2 to the 4 to the 0 will end in 2. 2 to the 4 to the first will end in 1, 2, 3, 4. Wait, 1 second. 2 to the 4 to the first is 2 to the fourth, right? This is 2 to the first, second, third, fourth. So something seems a bit off here. One sec. How can this be? These are so so if it's 2 to the fourth, shouldn't it just be one second? What is this? It's 2 to some power of 4, right? And any power of 4 will just be, it'll always be the fourth over here, except for when it's 0, right? If it's 1, 2 to the first, second, third, fourth. If it's 2, it's the 16. So 1, 2, 3, 4, 5, 6, 7, 8, 16, 16, 16, 16. So with 5,000, it'll be 6, and then you add the 1 over here for a total of 7. Okay, yeah, I just got confused by n is equal to 0. Oh, and never mind. They already said that n equals 0 doesn't work. So that's kind of stupid of me. But that's fine. Find the units digit of this. So, yeah, we'll do that. But right now my computer is almost out of charge. So let me just quickly charge it. I'll be right back. Okay, I'm back now. Wait, I'm changing the thing because so far I don't think anyone subscribed. So I'll write in the chat as well. Yeah. Anyone who subscribes and like stays subscribed, if you leave, it obviously won't count. Uh, I'll do 20 push-ups. I know that's not any motivation for you, but in case you want to do that, you can do that. And let's continue. Done with that one. Now 16 to the 17th, 17th to the 18th, and 18 to the 19th. So that's fine. 16 to the 17th. One second. First thing is that the way this works, it's going to be 2 to the 57th, right? Which is one more than a multiple of 4. So this will just be 2. So that's done. 7. With 7, there's probably another pattern, right? So it's 7, 49, 63, 63, then it'll end in 1, and then it'll go back to 7. So it's 7 to the 18th. So this would be the 4th. This would be the 16th, 17th, 18th. So this is 9. And then 16, that's just 6 basically. Like we're only looking at the last digit. Last digit will be will be 6. So that's 2 to the 17th times 3 to the 17th. We know 2 to the 17th is going to be 2, right? 3 to the 17th, that's going to be 3, 9, 7, 1 again, right? Yeah, 3, 9, 27, 81, and then back to 3. So this will also be the second term. No, sorry, 17, right? Okay, all this is correct. 3 to the 17. So it'll be the first one. It'll just be 3. So this is 6 times 2, 12 times 9, 108. So it'll just be 8. I hope, unless I made some mistake somewhere in there. Okay, great. I've passed the last digit base 10, but I want to master it. A book with 50 pages numbered 1 through 50 has its pages renumbered in reverse from 50 to 1. For how many pages do both sets of page numbers share the same ones digit? So I don't think we need to worry about like any flip type of stuff. Like none of that stuff. It's basically just so you'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? And let's just see what we got here. So we have 50, 49, 48, 47, 46, 45, 44, 43, 42, 41, 40. Then we'll have the same cycle. Right now with 12, it'll be, wait, what are they asking for? Let's just make sure we're reading it correctly. Only sets of both sets of page numbers share the same ones digit. So you can see that they're just offset by 1, right? They're off by 1. So I don't think it's ever going to happen. This will be 41. They're off by 1. They're off by 1. So it should be 0. I'm going to guess that. Okay, that's my intuition. That's what I think. Okay, good. Yeah, that's right. What is the sum of the tens digit and the units digit and the decimal expansion? Okay, this is a bit harder. How do you find the tens digit? There's a way for it, but I don't know. So first of all, the units digit. Well, no, wait, we don't really care. We just want the tens digit. Tens digit, right? So basically we need to take it mod. You want to take 9 to the 2004 mod 100, right? 9 to the 2004 mod 100. Whatever this is, then we can just then we'll have the remainder, and we can just do add the tens and the units digit there. So that's easy enough. We just need to get there now. So let's list out a few. There's 9, then there's 81, 729. What comes after 729? We ideally wanted to be like a small number that's easy to manage. Right, so you've got negative 19 to the 2024 mod 100. That might be useful for us if, like, 3631, which is 19 squared, was useful, but that doesn't seem to be the case. We can do 29, but 29 squared is 4. This becomes 1836, 81. Oh yeah, I already knew that. 841. So 841 is even less useful. So let's just go for one more. Let's see what happens after 729, right? Let's just see in case it's useful. So this becomes 1. You carry over an 8 here. This becomes 18 plus that. 26. You carry over a 2 here. So 63, 65, 65, 61. Again, this doesn't seem to be very useful for us. 81 mod 100. We basically, what's the scenario we want? We want the scenario. I just activated Siri by mistake. One sec. What the scenario we want is where it's like plus one, plus minus one to the 2004 mod 100. Now, I don't think we're going to get that. Right? We're not going to really get that. So, wait, actually, we can either get 99 or we can get 101. Right? This is what I'm guessing. Besides that, like, what are they going to have? They're not going to really have much. What else could be possible? Like, how does the question want us to solve it? If it was, if it were like 2 to the 2004, that would be pretty hard because it's not easy to get it mod 100. But maybe we can use 3, right? Take this and write it as, one second. Actually, yeah, this could be pretty useful because 9 is 3 squared, obviously, right? So let's just delete all this stuff for now. We can write this as 3 to the 4008. Let's see if there's anything special we can do with 3. So obviously still 3, 9, 27, 81, 243, not helpful. 729. But then after 729, what do we get? We get, um, I think we get 2187, right? And then after 2187, what do you get? You get 63. After that, it's a big number. But the point is that now this is just 13 away, right? We need to get something where it's plus or minus 1. Yeah, we wanted mod 100. So it's not easy. Let's see. Let's do one more here. 2187 times 3. So this becomes 1, you carry over 2 here. 24, 26, 2. Oh, this is just 6561 or whatever. Let's do one more from here though. This could be something. So it'll be 60. The last two digits will just be 3 times this, which is 183. So, right, 180, 183. So 83. Those will be the last two digits here. That doesn't matter either. Wait, I'm being stupid again. Actually, I shouldn't really worry about all of that. We can just worry about. We care about are the last two digits, right? So here we've got 43. Uh, yeah, that will save us some time and it'll allow us to work a bit faster. I don't know why I didn't do that yet. But basically 81 you multiplied, you get 243. Then you get 129. Then you get 87. Then after that you get 240. So you can ignore that. That gives you 40 plus 21. That gives you 61. Then you get 180 plus 3. So 83. 240 again plus 9. 49. Okay. Okay, wait. 249. This is 49. Right? 49 seems right about like very close to what we might need. If we can do it mod 50, um, that could help us. That could help us out a lot. So this is basically just equal to, and how many is this? This is 3 to the, we've got 3 to the 4008, right? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3 to the 10th, right? 3 to the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. So 3 to the 4000th would be this. Um, Wait, what am I even saying? This is negative 1, right? So this is equal to negative 1 mod 50. So we didn't get mod 100, we got mod 50, which could still be useful for us though. Um, Actually, how would it be useful for us? We'll see about that. But you know what? Let's try one more just to make sure we haven't missed anything good. The next one would be 47. The one after that would be 120 plus 21, so 141. Then we have 123. Wait, can you see all this? No, you can't, right? So let's zoom out a bit then. Next one would be 43. Sorry, 123. So 23. Then we have 69. Then we have ignore 60. That gives you 180. So you just care about the 80. Okay. We're a bit close now. 80 plus 27, which will in the end yield you. So 180 plus 27, that's just 7. Then you have 21. Then you have 63. Wait, actually, don't you have to have like mod 1 or something eventually? Isn't that the rule? Like you have to have it? I think it is. So, okay, let's keep going then. We're not that far now, I think. So 63, 189, so 89. This is a negative 11. So now it will become negative 33. Negative 33. Okay, there, finally. Now it will become negative 99, which is just positive 1. So, okay, let's just write it out then properly. 89, multiply it, 240, so this becomes 67. And after 67, finally, you have 1. Okay, so you've got 1 mod 100. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 3 to the 20th is congruent to 1 mod 100. Finally. So now we just have to do 3 to the 4000th will also be congruent to that. So we've got 3 to the 4000 is 4000. So 3 to the 4000 and 1, 2, 3, 4, 5, 6, 7, 8. 61. Okay, 61. So it'll be 6 plus 1, 7. Did they actually do it? I'm sure they did something interesting. They must have had a shortcut. And consider raising 9 to the 2004th. Oh god. N plus the 2004, which will have a negative 10 in them. Oh, yeah. Plus 1. So that's how they found negative 39. So again, remember that question which had the answer of 0 because I misunderstood or misread or whatever. That one we got lucky on. This one wasn't really luck, but it wasn't a good way to find it at all. It was like really long and tedious way, but it's fine. If A over B is the probability that the reciprocal of a randomly selected positive odd integer less than 2010 gives a terminating decimal, with A and B being relatively prime positive integers, what is A plus B? Has to be an odd integer. What odd integers work? It's just 5, right? 15 doesn't work. 25 works. Wait a second. 35 won't work. First of all, if it ends in 3, it's not going to terminate. If it ends in 1, it's not going to terminate. Wait, 1 second. What do you offer this? Randomly selected. Okay, 1 works, 5 works, 25 works. Is it just powers of 5? I think it is. I'm not 100% sure, but actually, let's see how far are we now. So we made good progress. Let's do this one. Let's do maybe repeating decimals, congruence, and residues or something like that. But I'll take a break in the middle. I can't do this for this long. And I actually have to go soon. I have a party today. So, um, if a over b is a probability that the reciprocal of a randomly selected positive or integer, so it's from 1 to 2009, right? So these are the possible, these are the total things. You've got 1 until 2009. So add 1, you get 2 until 2010. Divide it, you get 1 until 1005. So there are 1005 things in total. How many work? You've got all the powers of 5. You've got 1. You've got 5. So 5 to the 0. 5 1 5 2 5 cube. 5 to the 4th is 625. Is that it? Shouldn't there be like one more? 5 to the 5th will be over 3000. So not that. Now, is there anything else that's odd? I don't think there is. That doesn't make sense, right? So just 5 over 1005, I'm guessing. Take this out. This will become 201. So it's just 1 over 201. I think that's what they're asking me for. 1 over 201. So it's 202. Great. Okay, perfect. For positive integers n, let f of n return the smallest positive integer k such that 1 over k has exactly n. What? So there should be 2010 repeating decimal points. I have no idea about how to do this. Wait. For positive integers n, let f of n return the smallest positive integer k such that 1 over k has exactly n digits. So it should have 2010 digits after the decimal point. Uh, I'll be right back. Wait. I have to go right now. Give me. We'll take a quick break right now. So, oh wait, what's an intermission? Let's put that one. Okay, be right back. So, we'll take a quick 5 or 10 minute break because I've been doing this for almost over 1.5 hours now. So, I need a quick like break. Then we'll continue after that. And make sure to subscribe until then, so that when I come back, I have to do some push-ups. 20 push-ups per subscriber. That's a thing right now. Okay, guys, I'm back now. I kind of forgot actually about the live stream, so I got a bit sidetracked, but now I'm back. Okay, yeah, this one is okay. This one is. I think I have an idea about how to do it, or at least like how to do. One second, let me check that I'm unmuted and everything. Okay, so I have a slight idea, but I don't know if it's right. Basically, with three, um, you've got one repeating decimal, right? With three. Then with five, you don't have anything, but with seven, you have it's like 0.1. Let's see what it is. So it's 1 divided by 7, right? 1.0000000. 0 minus 0, 1 pull down 0. So 1. Let's just see what it is because I think there might be a pattern somewhere here. Um, if not, then I don't know what to do. So I'm just going to go with that. So 2 pull down 0 again. That gives you 20. So you'll put in 2 now minus 14. That gives you 6. Pull down 0. So it's not 9, it's 8 minus 56. Wait, can you see all this? No, I'm covering it a bit, so let me just move out. 2 and 5 are the only prime denominators. Yeah, they are the only ones. Logan, one second. But that's not really what the question is asking, right? It's saying, let's see, what is the question asking? It's saying it's not with the prime ones, yeah. Uh, wait, actually, yeah, you're completely right. 2 and 5 are the only prime denominators that terminate because the other ones are just powers of 5 or combinations of 2 and 5, which obviously aren't prime. So that's right. But anyway, continuing with this, I have to move this. One second. 60. So what do? We did 8, right? So minus 56. That gives us 4. Pull down 0 again. This will give us 5 minus 35. That gives us 5. We can put on another 0 there. This will give us 7. And then after we do 7, then we do. So sorry, this is just 50 minus 49, 1. And then when you pull down 7, you get the same thing. So it's this. It's got 6 digits repeating, right? It's 142857. Um, so this is 6. So this means it's 1 digit. This is 6 digits. What about 13? 13 is. Wait, that's not that. How can this be possible though? That has exactly n digits after the decimal point. Oh, it's not repeating with n. Stupid. Such that 1 over k has exactly n digits. Okay, so I think, Logan, what you're saying is it's partially right then. It's okay. Yeah, sorry, I'm an idiot. I read it wrong completely. So never mind. Um, yeah, then 1 over k. How many positive integers? So it has to be basically it'll be 2 to some power, right? So 2 to some power n, let's say, and then 5 to some power m or whatever. Okay, sorry about that. And then how many positive integers? So it should be 1 over n. So it'll have 2010 digits. Sorry, 2000 and yeah, 2010. So the smallest possible one. So we basically want to get to as small a number. So it'll be like 0. Um, this will be 2009 zeros, or wait, no, not necessarily. Basically just, okay, it's 2 to some power m to some power, but we want to do, we want to maximize the number, right? So we want to make this as big as we can. So we want to take the maximum of this, and we want it to be so that 2 to the negative n and 5 to the negative m. That looks like 6. When you multiply these two, what you get is, um, so it's 2000 digits long, which means that you want the biggest possible value. So it'll be, how can you do that? Do you have any ideas, Logan, on how to do that? Because, so to get 2000 digits, you can make n 2009 and m 2009, m 2009. This will give you 10 to the 2009, right? And then after that, I guess you can just make it same. Let's just try this. Let's put this in and see if we get anything interesting. So, wait, also, I think I'm blocking the stuff right now. Let me just move my picture down over here. Okay, so we can put in, if this is the case, then what will we have? We'll have 0 point, lots of zeros. Isn't it asking for the such k, minimum such k such that 1 over k has 2010? Minimum, or I think it's maximum. Oh, smallest. Okay, sorry. Again, another stupid mistake. So minimum. My bad again. Not repeating. Yeah, it has to terminate. Which, so okay. Um, if it was just n and m, then you'd have one decimal place, right? If n was 1 and m was 1. So if you have 2009, by that logic, you'll have 2009 decimal places. So the smallest number would then be, I think it would just be 2000 and some power of 2. It would work, but wouldn't that end up becoming more? Because basically, this will give you 0.0000. It'll give you 2009 zeros and then a 1 at the end, right? Instead, so what you're saying instead is that, and then this is obviously 2010 digits in total. If you use some power of 2, you'll have 2000 digits. I don't even know how to find that power though. Right? How will you find a number like that? Because it's basically like, it's something like this with so many zeros. So we won't be able to really find the number itself. And then they're asking, what are they actually asking for? They're asking for the number of positive integer divisors of um, k, right? The number of divisors of k. So I think we can do this, or at least we want to minimize it. So I think we can use some power of 2, but we also have to use some 5s, right? We can get to something like this. And then after this, so m to the 2009 will give you, so if n and m are both equal to 2009, this is what I'm thinking right now. Then we'll have um, 0.0, and then there are 2008 zeros, and then there's a 1 after that. Okay. What if we then do, to get it one digit lower, we can divide this by 8, right? Or actually, we can just divide this by 2. Okay, so if we divide this by just 2, think about it. This will now, instead of the point 1, which, so this has 2009 digits, right? Uh, oh yeah, wait, so 0 0.5, 0 0.25, 0 0.1. Actually, yeah, that's right, that's right. So 2 to the 2010. Yeah, 2 to the 2010. So then the number of factors would be 2011, right? Okay, wait, that's actually, you're completely right. I made like three or four mistakes or just stupid things in this question alone. So I hope this isn't the first time that you're watching the channel, because I'm sure you've got a bad impression, but I'm normally not this bad. Okay, yeah, so I think that's right, because to get 2010 digits, you'll need this, which means 2011 factors. Right, let's just check that's what the question is asking. Yeah, and that is the smallest one as well, right? Yeah. Okay, but do you agree on 2011? That seems right, right? I'll go and put it in for now. If it's wrong, then we can try again. But yeah, that's right. Okay, good. We got that right. Let's go back there because I want to get all of them to blue. So let's do one more. Okay, now this one I think I'll be able to get. Uh, let's do the same thing, right? Hopefully I won't mess this one up. It's until, so it's from 1 to 474, n over 475. So basically we need n over 475 to simplify to yeah, prime factorization. So that's, we can take out 25, that becomes what would it be, times 19, is that right? So 5 squared times 19, I think that's right? 25 uh, times 20 is 500 minus 25, so yeah, 5 squared times 19. So we need n to be a multiple of 19. N is a multiple of 19, and that's basically the only constraint, right? Is there anything else? It has to be, yeah, multiples of 19. Is there anything else though? There shouldn't be, because you've got 5 square in the bottom. So any multiple of 19, the first one will be 19, the last one will be, let's see, 380 plus 95. So 475 would be the last one, but it's obviously not that. So it'll be one below that. Fives work. Sorry, what? No, because five s work. Fives won't work, right? It's are you talking about fives for like, what do you mean by 5s or fives? Right, while you're doing that, let me just see this. So this will be 20, this is 5, so 25. And 24. So it has to be, so from basically from 1 to 24. So it should be 24 numbers, right? Oh wait, I'm actually again stupid. 25 times 19, we already knew that that will take you to 475. So it has to be 24. So it's from 1 to 24, which means there should be just 24 of them, right? And there are no special numbers, there are no exceptions here. Okay, done. We mastered that, I think. So they sent us here to repeating decimals. Okay. Find the fraction. Okay, this one is not bad. So 0 point, wait, 0.72 and then 6 repeating. So it's basically 72 out of 100, which is 18 out of 25, plus 6 out of 900, right? 72 over 100 plus 2 over 3. Yeah, exactly. So, um, yeah. Then 6, this is, what do you say? 2 over 300. So if we multiply, we need to multiply this by 12, right, to get there. Yeah, so 18 times 12. Wait, no, 2 over 300. Why do that? 18 times 6 over 150 plus 1. So 18 times 6 is 60, or wait, it's just 12. 9 times 12. So 108, 109 over 150. I think that's what it is, right? Okay. 109. Yeah. Is that That seems about right, right? Okay, good. Perfect. Good. Done. That section is also done now. So this one now. You recently bought more than 100 eggs. They're sorted in containers that can store exactly 12. Two containers each only hold 12. So it's basically a multiple of 12 minus 2. So the first multiple of 12 will be 108 minus 2. So it should be 106, I think. What is the smallest number of eggs? Because it's more than 100, right? Okay, I'll put it in. Let's see. Yeah, perfect. Find the integer n such that it's congruent to. Okay, so we can just take out. This is how many zeros? One, two, three, four, five. So it's 1,000. Oh no, not 1,000. 100,000 mod 7. So we can take out. So how do you? We can take out a 9,800. Right? We can take this thing out because we know that's divisible by 7, which leaves us with just two with 20,000. What can we take out? So actually we know that 21,000 works. So this is the same as negative 1,000 mod 7. Long division is faster. Okay, yeah, let's do that then. 7. This is 14285 or something, right? Which means that there should be I think there'll be 5 left then. That seems right. 1,000. 5? Okay, good. So then the answer here will be 5 as well. Which integer satisfies this? So negative 200 is congruent to n mod 19. So 190. So it should be um, negative 190 minus 10. So it should be 9, right? Because it's negative 190 minus 10, which is the same as adding 9. 9? Okay, good. Determine the tens digit. Oh, wait, let's do one more of those. A school declares a fifth Monday a marvelous Monday in any month with 5 Mondays. School begins on a Monday, September 4th. So if that's September 4th, then the next Monday will be on the 11th, 18th, 25th. So there won't be one that month, but it'll be. So what is it's September 4th. September is 9. So it's 9/4. And then the last one will be on. Oh, wait. Can you tell me how to do that? Settings. Oh, okay, here. Advanced Unreal Mastery. Thanks. Yeah, this one. And then September 4th, what's the date of the. Yeah, uh, done. I think there's a lag between the stream and the chat because of some latency setting or something. I'll try to fix that from the next stream. So, communication isn't perfect right now. Okay, anyway, September 4th. So the next one will be on the 11th, 18th, 25th. So 9/25. September, how many days are there in September? October has 31, so September should have just 30. Okay, okay, good. Yeah, I'm not good with that. So it'll be on the 32nd, which means it'll be the second. So it'll be 10/2. Then you'll have it on 10/9. Sorry, yeah, 10/9, 16, 23, and 30. So 10/30 should be the. I think that should be right, right? What is the date of the first? How do they want us to write this? So just write October 30. I think it is the 30th, right? It should be because it's 2, 9, 16, 23, 30. Yeah. So October 30. Okay, good. Modular arithmetic sums. If 1 plus 6 plus 11, so everything with 0 is less than n. Okay, so each of these is congruent to one mod. Well, no, not necessarily. Let's see. We should probably group these together in some way, right? Yeah, I think we can do that. So it's 1 plus 6 plus 11. So each of these sets is basically, each of these sets is basically 17, 18. So it's 3 mod 15, right? Each set is 3 mod 15. Let me screenshot the question and take it to the whiteboard over there. Yeah, exactly. Group by 3, since each of them increases by 5. And so every 3 will increase by 15. So the first 3 and every third, like every set of 3 is 17, 18. So it's 8 mod 15. Sorry, no, what did I just say? It's not 8, it's 2 mod 15. Sorry, 3 mod 15. Uh, let's see, we can figure that out. 15. So if you add 4 to everything, it starts from 5 until 105. Divide it by 5. What does this give you? 21. I think that's 7. The I might be wrong though. Because your plus 16, there should be 7 groups, I think. Right? Because, oh, wait. Yeah, because in total there are 21 numbers. So you divide it by 3 for 7 groups, I think. So 21, 3 times 6 mod 15 congruent to 3. I think it's right. Okay, so then it'll be 6. The final answer should be 6 because it's 3 times 7. So 6. Okay, good. Done with that as well. Patterns in modular arithmetic. Tens digit of 17 to the 1993rd. 17. So basically just 7 to the 19. Wait, is that correct? Yeah. So what is it? It's 7, 9, 3, and then 1. So 1992 will be there. 1993 will be 7. Let me know if the tens digit. Okay. Sorry, I got a bit too overconfident there. But yeah, you're right. So 7. Then we need to do 17, obviously. So, okay, we need to do, we can write this as, so there was one question where they did something like this. But I don't know if we can do the same thing here. I don't know if the same logic works here. So for that question, I just like bashed it and found like lots of different numbers. So 17 to 89. Then you multiply it by 17 again and again. But I don't think that's the right way, right? So 20 minus 3. Okay, so this, what will this end up looking like? It'll be 20 minus 3. Again 20 minus 3. 20 minus 3. Um, so there'll be all the powers of 20, right? Which are mod 100 maybe. Yeah, we're doing it mod 100. So right now, that's why right now I'm doing this because we'll get like 20 times 20 is 0 mod 100 because it's a multiple of 100. So that's what I'm trying to do here. We'll basically have minus 3 times 1993 times 20. And then I think we'll have minus 3 to the 1993rd. Wait, actually, will that even work? because basically each term will have some uh, factor of 20, some factor of 3. You need to make the 20 less than 2. So it can either be 1 or 0. If it's 0, then it'll just be 3 to the 1993rd, which will become, with all of these things, since I'm 1993, it's like negative 3 to the 1993rd, which will be just this. So that's what I've got so far, right? Now we need to simplify this though, and we can simplify that too, right? Should we do this with 9? So we've got this. Let's do 3 to the 1993rd, right? 3 to the 1993rd. This is 3 times 9 to the 1992 over 2. So that's 996. Okay, all of this, does all this seem right so far, Logan? Okay, just want to make sure. So we've got this. Um, this is just going to be 10 minus 1 to the 996, right? And so, yeah, it'll be 3. We just do the same thing as what we did there. It'll be negative 996 times 10, because it's minus 10 minus 10. Wait, will it be negative or positive though? I don't think I've. They're all getting multiplied together. No, they're getting added together. So yeah, this will be negative. Sorry about that. And then this will become plus 1 to the 9. Basically, just plus 1. This, yeah, this would be negative. Um, yeah. Okay, so I was just checking that. So thanks. Okay, we've got this plus 1. Now we just plug that back in over there. So what do we have? We've got negative 3. Wait, can you see all this stuff? Yes, you can. Let me just scroll down a bit. Negative 3 times 1993 times 20 minus, and then it's just all of this. So it's minus 3 times 1 minus 9960. Okay. We can take out a 10 from everything, right? We can take out a negative 3 first of all. So let's take that out completely. Negative 30 actually. This gives us 1993 times 2 plus, no wait, we can't take out a 10 yet. Never mind. So just ignore that. So, okay, negative 3, this stays the same. Then we have plus 1 minus 9960. This is what we have mod 100. I don't know. Yeah, now you can see it at least. Yeah, 99. Let's multiply that by 2, and then hopefully we'll get some cancellations, right? So this becomes, what does it become? 6. This becomes an 8. That becomes a 9. And that becomes a 3. 3986. Yeah, that's correct. Then there's a 0 here, but I'm not going to put that in yet. I'll just do minus 996 times 10. 1993 is congruent to 93 or negative 7. Oh yeah, I forgot all about that. You're right. Mod 100, right? So we can simplify all this stuff like that. 93 or negative 7. Well, actually now we're basically here anyway, right? So let's just finish this off. I think this will end in, this is already a multiple of 100, isn't it? You can change 1993 and that to 93 and 40. Yeah, I can. 93 will become, no, but we don't really, um, we don't need to do that though. I think this is a bit faster actually. What you're saying is also right, but I think I could have used that and that would have been as fast. But now that I'm here, I'll just do this. Basically, this will end in a zero. So this is like 10 times something, and you're multiplying it by 10. So this entire thing cancels out. Uh, 93 and 40. I can. So then this will become 93 minus 1486. So this becomes 86 minus 40. Wait, actually, what am I doing? What makes more sense, your thing or my thing? Over here, this already cancels out. Basically, I just took out the 10 from here and here, and I got this minus this, which is a multiple of 10 because it's like 6 minus 6. Okay, thanks. Yeah. I think if I used yours earlier, then I would have that would have been faster. But since I already started with this, now mine makes a bit more sense here. Anyway, this all of this goes away. So we're just left with negative 3 um times 1, right? So that's negative 3. So it'll be 97, I think. Right? Just confirm if that seems right, like all the steps that I did. They seem reasonably accurate. So yeah, 1 negative 3. Uh-huh. I didn't do that. I did like 1 second. I'll make it a bit neater. I'll do it over here on the side. Let me move my camera again. 1 second. Okay, I don't think you're missing anything. I think I just erased that part. So basically, we've got 1993 times 20 minus 1996 times 10 plus 1. And then all of that is multiplied by negative 3, right? 1 second. Let me. Okay, makes sense. It's very possible that I'm just doing something wrong. So let me know if that's the case. Then this ends in a 6 and this ends in a 6. If you multiply this by 2, right? So this becomes what a 3986. Okay. I'll let me just work through the rest of this and make sure. So all of this becomes 0. So it's just 1, negative 3 times 1. So that will be 97. Um, because it's negative 3 mod 100. Right? So it should be 9. Yeah. Let's put it in and see. Okay, it's wrong. The tens digit. 17 to the 19. What did I do wrong here? Let's see. So maybe let's just okay, so we know the last few steps. If I got until here correctly, then it seems right. So let's see, maybe there's some sign error. I think I've got a feeling that that's the problem. Okay, 20 minus 3 to the 1993rd. You'll keep on getting stuff like, oh, did I not do this part properly? I think I did. 3 times 9 to the okay, so I included the 3 there. 996 times 2 is, did I do that correctly? That I think that's very possibly what went wrong here. In if I did that wrong. 996 times 2 gives you 1992 plus, so it's 3 to the 1992. Yeah, okay, so that part is correct. This expansion seems right as well because it's negative 1 to the 996, so that will be plus 1. Negative 996 times 10. Um, Again, that seems right. So this step seems right. Okay, this checks out or whatever. At the same time, this Um, this also seems right. Negative 3 times 1993 times 20. Yeah, that's right. And then it's minus 3 to the 1993rd. And it's minus because it's an odd power and it's negative 3. Yeah, that's right. Okay, so we got all that so far. Negative 3, when we take out negative 3, do we do that step correctly? 1996 times 10. This becomes 3986 times 10. This gets subtracted. I think, okay, let's look at it and see because I'm not being able to find mistakes and I think I have to go actually in like 13 minutes or so, like 1 3. So I'll need to be a bit faster here. Okay. Yeah, so it should be 97, but if that's wrong, then I'm in the tens digit. In case I think it's possible that it's just like a sign error and it was plus 3 instead, because that seems the most likely. Like this. I think that seems the most likely right now, and I don't want to take too much time on this. Uh, my dad just told me to hurry up since we have to go. So, let's just leave the. Let's just guess 0 because it'll be plus 3 and see. Okay. So they did. Let's see what the answer is first of all. It's 37, which is like completely off what we got. 1037. If Okay, so basically they got to 21. 17 to the fourth is going to 17 times 89, 30. Yeah, I think what did we do? We just went right off the bat. We immediately did like 20 minus 3. So we should have done a little bit of trial and error. Or not trial and error, just gone until that. Then what do we have? What did they do after that? So they use the powers of, so 17 to the fourth. Then they got the period. They got it to be periodic. So 17 to the 20th. Okay, that's the key one. And then from 17 to the 20th, they were able to get to 17 to the 80th. So they just needed 17 to the 13th. Yeah, that makes sense. And then 17 to the 12th. So they found that. I guess by just doing like 21 cubed or something. Not sure. Right, 21 cubed. Uh, Let me just see what that is. Yeah, they did 21 cubed, which gave them 9261. So 61, then times 17, and then okay. Uh, that's good then. So okay, in the future we can do that. What is the residue of this modulo 17? Okay, so we need to basically look for a power of 9 that's very close to a multiple of 17, right? And so there's 1734, then 51, 68. None of these are that close. 85. Let's see, 85. I want to get like just one off. Okay, we should do it with 9 instead. That's probably faster. 9. And since it's 9 to the 2010, maybe they want us to do 3 as well. Maybe we can include that and see. So it's like 3, 9, 27, 81. None of these are that close. 243, is that anywhere near a multiple of 17? It could be. So let's see. 17 times 17, 289. Okay, 9 to the fourth. Perfect. So 9 to the fourth is congruent to 16 or negative 1. So then 9 to the eighth is congruent to 1. Exactly. And well, we can go off from the, yeah, okay, 8. That means 2000, 2008. So 9 to the 2008 is congruent to just 1 mod 17, right? That's what you got. And so then after that, it's just 9 times 9, 81. Because you just, yeah, 81 mod 17. And what's that? That's negative 4. So that should be 13, I think. Okay, just check. 13 seems right. Okay, perfect. Good job. That was, that saved a lot of time. And yeah, that's exactly what they did as well. What is the remainder? Okay. Um, this is the same thing, right? Basically, I think we can easily get to 50 when we use 49, but that isn't, but we want to get to 100. We don't want to stop at 59. So we need to get to 99, 101, something like that. So there's 7, then there's 49. We just care about the last two digits, right? 350. So 343. What else? 280. Oh, the next one is 301, right? So this is 1. So 7 to the fourth is congruent to 1 mod 100. 49 squared. Yeah, that's 7 to the fourth. So I think we got the same thing. 2401. Okay, great. 2010. Again, it's 2010. So it'll just be 49, right? Because 7 to the 2008 is also congruent to 1 mod 100. So it should just be 49. Let me know if you get that too. I think it is 49. This could be good. Yeah, perfect. Great. Let's see. Determine the units digit of this. So that's 17 times 17 squared minus 1. So that will be 17 times 18 times 16. So 6 times 8 times 7. So this is 2. Sorry, this is ends in a 2 times 8, so 6. Right? Oh, 13th. Okay, sorry. My bad. Never mind. So 17, then, so what power is 17 raised to 13? You're correct. I read it wrong. 13. Um, so this becomes 17 to the 12, only mod 10. It's, wait, we don't, yeah, wait, actually, we don't need to actually expand any of this stuff, right? 17 ends in 7. So it'll just be 7, then it's 9, 6, sorry, 9, 3, 1. And it's to the 13th power. So it'll be 7 minus 17. So this should be 0, I think. I'll try it now. And yeah, okay, it's correct. Because 17 to the 13th ends in 7. Find the remainder when it's divided by 13. So what's a good power that we can use for this? 81, 78. 27. 27, right? Perfect. That's one more. So 3 cubed is congruent to 1 mod 13. Just let me know if these steps are correct. So that means that, yeah, perfect. And then 3 to the 1999. What's that? It'll be 1998 because that's a multiple of 3 is congruent to 1 mod 13. So 3. Okay. That's what I got to. What is the remainder when this is divided by 13? Um, we can put all the powers of 2 together, right? We'll get like a big thing over there. So it's 2 to the 27, 30, 40, 47. 2 to the 47th. That's what I got here. Times 3 to the 7th, I think. Uh, right? Does that seem right? Wait, sorry, over here. Then we know that 3 to the 7th is congruent to just 3 because it's like every third. Um, 2 to the 47th. So there's 2. Let's see, we want a power right next to 1. 2 to the 47 times 3 mod 13, 26, 52. Okay, 2, 64. Right? 64 is 2 to the 6th. That's congruent to negative 1 mod 30. So we can do 2 to the 12th. 2 to the 12th is congruent to 1 mod 13. So 2 to the 36. 2 to the 48th. 7 cubed. Wait, was there a 7 in there? 7. Oh, 7 times 3. Okay, no, not cube. 7 times 3 congruent to 8. Um, 2 to the 60th is 1. Yeah, 2 to the 48th is also 1. 2 to the 36th. Let's just do 2 to the 42. Right, that will be negative 1. Then we multiply it by 2 to the 5th. So times 32. So it's negative 32 times 3. That's what I've gotten so far. So negative 96. So 96. 13 goes into what? What does it go into? So wait, 1 second. 13 goes into 78 and then 91. So it's just 5. Right? Wait, I'm in like a big hurry now. Like 2 minutes I should be leaving. So I'll try to just finish off this section. 8. Okay, how about... Okay, let me try 5 first. If that's wrong, then I'll try 8. Okay, because... Okay, then 8. Okay, nice. Messed that up. Oh, it's negative 1 to the 7 times 32. So 3 to the 7th is nothing then. Uh, mod 13. Okay. Negative 32 is... Oh, wait, yeah, negative 32 isn't going to be... It was negative 96, right? 3 to the 7th is 3. Okay, so did you get negative 96 then? Or... Okay, that was correct. So then what did I mess up here? Negative 13, negative 96. Oh, 7. Okay. Yeah, because it's negative 39 plus 7. Okay, that's... I can't go from negative 96 to 96. That seems wrong. But, okay, so we still got that right. Thanks to you. Um, the infinite sequence T defined by this was T sub 0, T sub 1, T sub 2. It's defined 0, 1. It's the sum of the previous two. So it's basically the Fibonacci sequence, right? Or like some adjusted version. Yeah, it is the Fibonacci sequence. 0, 1, 1, 2, and so on. If A, B, and C are fixed non-negative integers such that A is congruent to 5, B is congruent to 10, C is congruent to 15. What is the remainder when that's divided by 7? Okay, T sub A. So it's not just like A, obviously, it's T sub A. Let's just take a look and see what we get. Let's just list out the first few, right? Mod 7. So we have 0, 1, 1, 2, 3, 5, 8. Casework? Yeah, I think so too. So, well, something like that. Yeah. Uh, 1, 2, 3, 4, 5. No, sorry, t sub 0 is this. So this is 0, 1, 2, 3, 4, 5. Then we have, then we get 13, 21, 34, 55, and then we get what, 89. Let's see. So this is 6, 7, 8, 9, 10. So at 10 we have a remainder of 6. Wait, can't we like just guess and check? We can just say that it's A is 5, B is 10, and C is 15. We can just take those as the values, figure them out, add them up and divide, because basically we found the 10th one, right? That's mod 6. This is remainder of 5. Okay, good. So we just have to find the first few values and then we're good to go. 55, 89. What's after that? Um, 144, I think. Yeah. Uh, 11, 12. So there's still a few more to go. Right, let's see. 89 plus 144 is, well, yeah, this will be 3. This becomes 1. So 9, 3 again, 233. Then after that, you do 144 again. So this becomes 377. When you add these up, you get 610, I think. Right? 233 plus that's 500. 610. Yeah, perfect. So 610. This is negative 20. So negative 21 plus 1. So this is 1. So 5, 6, and 1. Mod, yeah, so you just add them up and you'll get 5. Mod 7, I think 5. Okay, perfect. Leveled up. We're still one away. If this is an easy question, okay, this doesn't seem too bad. 5, yeah. That was the answer there. Last question. After this, I do have to go, but we've done a lot. Like especially working with you, Logan, because before that I was going pretty slowly, so I was able to pick up the pace quite a bit after that. What is the remainder when 5 to the 207 is divided by 7? We just need some close powers, right? So 5, 25, 125. 7 goes into 126, right? 7 goes into 126. So 5 cubed is congruent to negative 1 mod 7, which means 5 to the 6th is congruent to 1 mod 7, which means 5 to the 204. So 5 to the 204 is congruent to 1 mod 7. So it should just be, really, what is it? It's got, obviously it's got a 9, then becomes, wait, I'm kind of blocking it out right now. I don't, okay, so we've gotten all the way to 5 to the 204. That's congruent to this. Then it's 125. So it'll just be negative 1, right? It should just be negative 1. Oh, meaning 6. So I'm going to put that in and see. Correct. Okay, done. Since we're so close now to finishing this one as well, I'm going to, this is a short unit, like an easy one. So basically this has to be a 1 or 1 plus 3, 4. So it has to be 4. Done. One more. What is the smallest 4-digit number that is divisible by 33? So 99 goes into it, which means 990. Let's see, 990 plus 33. 3210. 1023. Okay, done. Now that's it, because I really have to go now. So thanks a lot for watching. If you want to like do join more streams and do this sort of stuff again, just subscribe. Okay, because then obviously you'll be able to see when the new streams come out. I'm planning on, I can't do any tomorrow, but I'm planning on making a lot more of these in the future. Now we're almost done with number theory as well, which is very good. So I have to go now, but uh, I'll make sure to do this in the future. It was really fun working with you as well, Logan. So thanks a lot for that. Okay, so I'll see you in the future then. So see you soon. Okay, bye then, and I'll end the stream now. Thanks everyone for watching.